Hello everyone. So today we will work on the 0-1 knapsack problem using the dynamic programming approach. I will teach you the concept as well as the formula that we will use to solve it. Okay, and we will try to do it as quickly as possible. So first of all, let's understand the problem, right? Problem understanding is very important. So we have a bag. What is a 0-1 knapsack problem, right? We have a bag and we are calling it the knapsack actually, and it has some limited capacity, let's say 15 kg or whatever. So we have to fill this bag with different items, and while doing so we have to keep in mind the constraint that the total weight of all the object should be less than or equal to the capacity of the knapsack, obviously, of course. And the objective is to maximize our profit. So this is what a knapsack problem is. Now this is a 0-1 knapsack problem. That means we cannot keep a fraction of any object. We are either keeping an object or not keeping it. So that's why 0 or 1, right? Binary. So let's solve it now. So mathematically our problem is this: we have to maximize the profit. V is the profit. In some books you will find P for the profit, and in the others maybe you will find V, so it's fine. So we have to maximize the total profit, and the constraint is that the sum of all the weights of the items that we are keeping in the bag should be less than or equal to the total capacity of the knapsack, right? I is the number of item. I1 is the item 1, I2, and so on. So we have total, let's say, n items, and we have to choose the combination, that combination which gives us the maximum profit, right? This is our problem. Okay, let's start. So before explaining you this, let's first see how we will actually be solving it. So basically we will actually make a table, right? So let's start with an example. So we have this example: the total capacity of the bag is 10, and these are our items. So this is the profit of the item number 1 and the weight of item number 1. And similarly, this is the profit of item number 2 and weight of the item number 2, and so on. Profit of item number 3, weight of item number 3. Profit of item number 4, or the worth of item number 4, and weight of item number 4. So this is our problem. So what we will do is we will make a table. You know, in dynamic programming, we divide the problem into subproblems, and then overlapping subproblems, and then we solve it. So we will make a table. Now there are two main important concepts, or two key points that you should know, and if you understand those 2 points, everything else is easy, right? So let's focus on that. Okay, so the first point is basically I'm explaining you what this table is all about and how we will be going to fill it. So the first point is, this is a table, and W is the weight. So this means the allowed capacity or the allowed weight is 0 right now, and this means the allowed weight is 1. This means the allowed weight is 2, and will go on up till 10 because that is the total capacity. So the first point is that when we are in this column, we can only put those items whose weight is equal to 1, or the combination of those items whose weight is equals to 1. If we are, let's say, in this column, the 5th column, so we can only put that item or a combination of those items whose total weight will be equal to 5, not 10. 5. So this is the first point, that in each column the allowed capacity is the one that is written over here, not the total capacity, right? So it makes sense. This is a dynamic programming approach, and in that we divide the problem into subproblems. So you can think of these as subproblems where the allowed capacity is currently in this column is 3, not 10. So this is the first point that you should grasp. Okay, the second point is in each row, this is item number 0, this is item number 1, 2, 3, 4, right? So in each row the allowed items are, for example, if I am in this row, right, so the allowed items are item number 3 or any combination of the previous items. So if I am at this row, I am allowed to only pick item number 1 or the ones before it, and there is no item before it because this is item number 0, there is no item number 0, right? So if I'm in this row, I can only pick one item. If I am in this second row, I am allowed to pick item number 2 or item number 2 plus 1 or item number 2 plus 1 plus 0. Basically, there is no item number 0. And then if I'm in this row, I'm only allowed to pick item number 3 or a combination of the previous items, not the ones ahead of this, right? So I'm not allowed to pick item number 4 when I'm at row number 3. Basically row number 4, basically in this row where I equals to 3. So these are the two very important key points. So if you understand these, everything else will be easy. Now let's start solving it. So you have understood the two main points. These columns are the allowed weights and these rows are for the allowed items. And the value we will be writing in these boxes will be the worth or the profit, the V, right? This one for each item. Okay, along with this table, we will be maintaining one more table, and that is called the keep table. This one. It has the exact same size, exact same rows and column, and we will be writing 0 or 1 in these boxes. And how will we decide whether to write 0 or 1? I will be showing you that in a while. Okay, so let's start filling this one. Okay, so now when I am allowed to pick up item number 0, there is no item number 0, you can see it over here. So when I'm allowed to pick item number 0, that means no item, I'm not allowed to pick any item. The total allowed capacity, if it is 0, if it is 1, 2, 3, no matter how big my bag is, no matter how much I'm allowed, no matter how much the capacity is, it does not matter because I'm not allowed to pick up any item. So that means the worth will be 0 in this whole row. That's it. Just fill the whole row with zeros, right? Similarly, when I am in this column, my allowed capacity is W equals to 0. That means 0, no capacity. So no matter how many items I'm allowed to pick, the worth or the profit will always be 0, right? So I'm going to write 0 all over here. My pointer is doing some problems, so just you have to bear with it. These are all zeros. Okay. So this is what I was saying in the previous slide. Let's go back to the previous slide. These are some base cases, and you will understand them more easily now. So this means that when I'm not allowed to pick up any item, so no matter how much the capacity is, the worth will be 0. So for W, starting from 0 till capital W, the capacity of the bag, no matter whatever the capacity is, no matter whatever the capacity I'm allowed to pick, but there is no item here, so the worth will be 0. Similarly, when there is no item and if the capacity is less than 0, this is an invalid case. If that happens, when we are solving this for the formula, if this happens, this is an invalid case. Now, if I'm allowed to pick any item I, but the allowed capacity is 0, obviously that in that case, the worth again will be 0. This was the first column that we just filled with zeros, right? Similarly, in this last one, if I'm allowed to pick up an item and I am allowed with a capacity, but that capacity is less than any item, available item, then this will also be 0. So if you don't understand this last one, it's fine. While I'm solving the example, you will get a better hang of it. Okay, so this is my formula. We will be using this formula. So basically, what we will be doing is we will be choosing among one of two values. So we will be choosing the maximum of either this one or this one. So you can very clearly see that this is I minus 0. That means the previous value. So we will be choosing among the previous one or the next one, someone that I has some contribution to. So basically, these two formulas are exactly the same. So for some people, this W can make some confusion, right? Because this W and this WI over here may get mixed up. So I have just replaced this W with J, and that's it. So this is exactly the same formula. So basically I is the item number, W is the allowed capacity, not the total capacity, the allowed capacity, and WI is the weight of each individual item. So for example, WI for item number 1 is 5, for item number 2 is 4, that's it. And W is basically the allowed capacity, this one. For this column it will be 2, for this column it will be 4, and so on, right? So I'm sure you have understood the formula well. Now let's start solving it. Okay, now let's come to this box. So when I equals to 1 and I'm allowed to pick up the capacity I'm allowed with is only 1. So what is the weight of I? You can very clearly see here that the weight of I is 5. That means it cannot come in a bag which is of size 1, right? And basically this is this case, this one, which we just talked about. So we cannot put it in a bag which has the size 1. So of course this must be 0, right? Similarly, it cannot come in a bag of size 2 because the item is of weight 5. So this will be 0, this will be 0, and here we can write the profit of item number 1, because this is a bag of size 5, the capacity is 5, and the weight of item number 1 is 5. So I can write 5 here, right? So this is how I will do it conceptually, but let's do it through the formula. So this is my formula. Right now our I is 1 because we are doing it for the item number 1, and our J is 5. Why? Because I'm solving it for this particular box. So here you can see the I is 1 and J, or the allowed capacity, is 5. So this is I, J, 1, 5. I'm doing it for 1, 5. So for 1, 5, just put the values. If I is 1, I minus 1 will be obviously 0. J is 5, and then V of I obviously will be V of 1, and V of I minus 1, 0. J will be 5, and Wi is basically W1. And just put the values. So W1 is the weight of the first item, which is 5. I put that here. V1 is the profit of the first item, and that is 10. We will put that here. Now let's see what is V0, 5. So for V0, 5, we have to go back to the table. So V0, 5. So basically we are referring to this particular value here, the previous value basically. This is 0. So we will write 0 over here, 0. And what else? We have written everything else. Okay, so 5 minus the weight of the item. 5 minus 5 is 0. V0, 0. So we know that this is the first item. It is obviously 0, but let's see. V0, 0. Right? The value is 0. So 0 plus 10 is equal to 10. So this 0 plus 10 is equals to 10. And then maximum of 0, 10 is obviously 10. So very simple. Right? So this is the profit. Oh, I did a mistake. I'm really sorry. We didn't have to write 5 here. We had to write 10 here. Why? Because I just told you I will be writing the V over here. This V, this value basically. So this is wrong. I should have written 10 over here. Let me correct it. Sorry for that. So I have to write 10 over here. And with the formula, we also found 10. Now let's understand the keep concept. So while solving this formula, in very simple words, if you are choosing if we are choosing the value which comes from this side, then we will keep the value of keep as 1. And if we are choosing something which comes from this side, then the keep will be 0. What this means is, if you're choosing something from the previous value, if the maximum or if the chosen value is from the previous box, it is 0. We're not keeping it. And if the contribution of this answer comes from I, something from I, then we keep it. So when we are choosing, here you can see we are choosing 10. The maximum of these two is 10. We are choosing the right side. So we will keep the this value 1. Keep 1, 5 is 1. And we will put that in the table over here. So keep 1, 5, 1, 5 will be 1. And all of these are 0 obviously. previous one. I'm talking about the previous one, not the future ones. We will be calculating those. Why am I using this keep table? Because after solving it, it will help me decide which items to keep. That's why we are keeping it. Okay, that's it. We have done this one. And let's go back to our table. So here, if we see it conceptually, can I pick any other item before 1? There is no other item. Item I0 means no item. There is no 0th item here, right? So I'm only allowed with item number 1. There is nothing behind it. In the future rows, I will show you, we will be using the previous values, but here there is no previous value. So I can only pick up item number 1. So even if my bag size is 10, I will only be picking up item number 1. So the value here will be 10. Similarly, even if the bag size, even if the capacity, allowed capacity is 7, I will only be keeping item number 1 because I'm only allowed with that. Similarly, it will go on till here, but I will also do it with the formula. Just write these. Let's do that. Let's solve this with the formula, because when you are making a program, when you are writing the code, this is just how you're doing it conceptually, but when you're writing the code, you need the formula. You need a concrete reason why you are doing this, right? So formula is important. And obviously we can only fill this keep table while we are using the formula, right? We can decide that with the formula. Okay, so let's do it for 1, 6. So v of 1, 6, put all the values. I is 1, so this value will be 0, and j is obviously 6. So 0, 6, v of 1, 0, and 6 minus v1. v1 is 5. It will be 5 for all the v for the first item, right? Now 0, 6 is 0. You can confirm that from the table. This is the cost or the worth or the profit of the first item, and 0, 1 is also 0. Okay, let's confirm it as well. So 0, 6, 0, 6 is 0, and 0, 1 is 0. Both are 0. Right? So obviously the maximum is 10. Similarly, when we are doing it for 1, 7, the maximum will be 10. And obviously we are choosing the right side. We are choosing something where I has the contribution, right? Not the previous value. So we will keep 1, 6 as 1. We will keep 1, 7 as 1. Similarly, for 1, 8 and 1, 9, the answer is 10, and we will be keeping I, 8 and I, 9 as 1. And the same is the case for 1, 10. And keep of for 1, 10 is also 1. Okay, let me fill in the keep table. So this is 1, this is 1, 1, 1, 1. Okay, let's do it for this one, item number 2. So for item number 2, okay, let me change the color. Let's use blue this time. Okay, for item number 2, the total weight of item number 2 is 4. That means you cannot put it here, right? Yeah, you cannot put item number 2 here because the allowed capacity is 1. So I will write 0 here. This is same, the base case that we just talked about. Then if the capacity is 2, I cannot keep item number 2 because the minimum capacity is 4, so it will be filled here. 3 will also be 0. Okay, now at 4, I can put item number 4 here in the bag. So I'm gonna write the profit of item number 4. Okay, last time I made the mistake of writing the weight. Let's not do it this time. My pointer is very horrible right now. Okay, so 40 over here, and let's find it through the formula as well. So I'm gonna solve the formula for I equals to 2 and j equals to 4. 2, 4. We have just done these ones. These are the base cases. So for 2, 4, put the value of I as 2. So 2 minus 1 is equals to 1. Therefore, this 1 here, j is 4. So you know v1 comma 4, and v now I is 2, so v2 plus I minus 1 is 1, 2 minus 1 is 1, 1 comma j is 4, 4 minus w2. So what was w2? W2 is 4, right? So just write 4 over here, and 4 minus 4 is 0. So we have to find v1 comma 0, and we have to find v1 comma 4 comma, this is the worth of the profit of item number 2. Okay, let's quickly see what is 1 comma 4 and 1 comma 0 in the table. 1 comma 4 and 1 comma 0. So 1 comma 4 is this 0, and 1 comma 0 is this 0. Right, so putting this as 0 and putting this as well 0, so 0 comma 40 plus 0, that is 40. So we will be choosing 40, we will write 40, and we just did that conceptually. And obviously the keep will be 1 because we are choosing the right side, we are choosing something where I is making the contribution. So this will be 1. Similarly for 2 comma 5, same procedure, we will be choosing 40 and we will be keeping 2 comma 5 as 1. Same case for 2 comma 6 and 2 comma 7, 2 comma 8. Okay, interestingly 2 comma 9 is different. Okay, before solving this one, let me show you this conceptually on the table. 2 comma 9. So conceptually, I was allowed to pick up all the previous items if I'm in this row, right? So that means I can pick either 2, and I can also pick a combination of previous items. That means what if I pick up both these items, 2 and 1? What if I add those? So if I want to pick both these items, I should know the weights of both these. So the weight of 1 is 5 and the weight of second is 4. So 5 plus 4 is 9. So I can only pick up these 2 items and put it in my bag if 9 is allowed. Is 9 allowed? Yes, 9 is less than 10. So 9 is allowed, and 9 is over here. That means I can only put them over here, not before that. So before that, I will continue the previous value, 40. And this is what we found through the formula. This is 40, not 46. Okay, at the 9 capacity, when the allowed capacity is 9, I can keep both the items 2 and 1, right? And what will be the worth of both these items? 40 plus 10, that is 50. So at this point, I will write 50. Similarly, in the next column, when the value of the allowed capacity is 10, I can also keep both these items, that is 50. Now let's solve it using the formula. Right, this one here. So when I equals to 2 and j equals to 9, put it in the formula. 2 minus 1 is 1. So 1 comma 9 here, 1 comma 9. v2 plus I minus 1 is 2 minus 1 is 1, comma. Okay, j is 9. This is 9 over here. So j is 9. 9 minus w2. So w2, the weight of second item, is 4. We know that. So 9 minus 4 equals to 5. So this is what I have to pick. v2 is the profit of the second item, which is 40. So 1 comma 9 and 1 comma 5. Okay, let's check what is 1 comma 9 and 1 comma 5. So 1 comma 9, this is it. This one, this is 10. And what was the other one? 1 comma 10. 1 comma 10 is 10. What was the other one? 1 comma 9 and 1 comma 5. Sorry, 1 comma 5. So 1 comma 5 is 10. Both of these are 10. Okay, let's put the value. 10 comma 40 plus 10. So the total is 50. So that's why we have written 50 over there. We can keep both the items. And similarly for 2 comma 10. And obviously the keep value will also be 1 for all of these. Let's quickly fill the keep table. So 0. All of these were chosen with the contribution of I, that is the right value was chosen. Okay, now let's do it for item number 3. So okay, let me choose the pen. So the weight of item number 3 is 6, right? So that means it can only be fitted over here, right? Not before that. So even if the capacity of the bag, if the capacity of the bag is 2, I cannot keep item number 3 here, and so on. So these values will be 0. So I will write 0 over here, 0, 0. But over here, whenever we are writing a value, actually we see the previous column or the previous row. So whichever one is larger or maximum, we choose that. So in all the previous cases, everything was 0. So we were just putting in 0. But this is now a new case. Whenever you are filling the box, always look towards the previous column or the previous row. So whatever is maximum, put that over here. So right now 40 is maximum, so I'm going to put 40 over here, and same is the case over here. Okay, at this place I can fix item number 3. So what is the cost of item number 3? It is 30. That means I have to write 30 over here, but so 30 should be written over here, right? But 30 is 30 less than or greater than the previous column or the row? So obviously 30 is less than both of these. We won't be writing 30 over here. We will actually be writing 40. We have to choose the maximum of the previous one or the current one. So we will be writing 40 over here. But let's confirm this through the formula. So I'm going to apply the formula starting from here. 3, 4, and we will find this 40 through the formula. So when you are writing the program, you know what value to choose, right? Let's do that. So I equals to 3 and j equals to 4. Putting these values in the formula. Let's see. So I equals to 3 and j equals to 4, right? So put these values in the formula. 3 minus 1, 2, and j is 4, so 2, 4. And the cost for item number 3. And then again, I minus 1, that's 2. J is 4 minus the weight of third item, which is 6. So 4 minus 6 is minus 2. Now this is interesting, right? So you can see this is very clear. V2, 4, 30. 30 is the cost of this item number 3. But this is very interesting. You can see V2, minus 2. So this is an invalid case. The J value or the allowed capacity is minus 2, and we saw this in the base cases. So if there is a negative number here, this is an invalid case, so we will not be considering this. So we will only consider this left side, which is 2, 4, and the value for 2, 4 is 40. We can quickly confirm this, the value for 2, 4 in our table. So this is 2 and this is 4. This value is 40, right? So we will only consider this left value, and we will not be considering the invalid value over here. Therefore, the answer is 40. Now, interestingly, you can see we have made a decision based on the left item. So there is no contribution of I over here. So since we have chosen something from the left side, the value of keep will be 0, right? There is no contribution of I over here. And same is the case for the following one. V of 2, minus 1. So minus 1, again, this is an invalid case, and we will not be considering this. We will only consider the left side, which is 2, 5, and the value is again 40. So keep value for this will also be 0, right? Okay. Now let's consider the 3, 6, V of 3, 6. In this case, this is basically, let me remind you, this is basically 3, 6 is this case over here, which we just made a decision for, this one, where we decided we will not be putting 30, the cost of third item, but that cost is, why? Because that cost is less than the previous column or the previous row. So we won't be putting that. So we are now solving it through the formula. V of 3, 6, third row and sixth column. Like I equals to 3 and j equals to 6. Okay. So 3, 6. All right. Now I equals to 3. So 3 minus 1, 2. And obviously 6. So 2, 6, V of 3. and 2 will come here, and 6, j, the value of j is 6. V of I, which is basically v of 3, is 6, right? 6 minus 6 is 0. So finally our value is v of 2 comma 0. So v of 2 comma 6 is 40, and then v of 2 comma 0 is 0, and we can quickly confirm v of 2 comma 0. So v of 2 comma 0, this value over here, you can see this is 0, right? So 0 plus 30 was the value. Where is it? Yeah. So 0 plus 30, that is 30. So 40 comma 30. Again, we are making the decision based on the left one, no contribution of I, and the value of keep will be 0. We are choosing the left side. And same is the case over here. So value of keep for all of these, 3, 6, 7, all of these, and the previous one, 4, 5, it is 0. Similarly for 3, 8, again, we are choosing the left side. Again, we are choosing the left side. So the keep is 0, not 1. Okay. Let me fill all these values till 3, 9 for keep. So keep is 0 over here, 0, 0, 0. This is 0. And the other table, the actual profit table. So we just found these values through the formula, and conceptually again 40 plus 40, and this is again 40. We will write 40 over here. And basically, so when I'm in the third column, I am allowed to pick up any of the previous item, any combination of the previous item. So when I picked 3, this is where it would have come. And if I pick 3 plus 2, third item and the second item, so what is their combined weight? Third item is 6 and second item is 4. 6 plus 4 is 10. Yeah, I can pick that up because 6 plus 4 is 10, and 10 I am allowed with the weight 10. So 10 is the total capacity. So what is their combined profit? Their combined profit is 30 plus 40, 70, right? And 6 plus 4 is 10. That means here, this is the place where both of these can come together. What if I pick up 3, 1? Can I pick up that? So 3, 1. So that is third item has the value 6, the weight 6, and the first item has the weight 5. So 6 plus 5 is 11. I cannot pick that up because 11 exceeds the minimum capacity of the knapsack. And similarly, how about 3 plus 2 plus 1? Obviously, I can't do that either. So 3 plus 2 is 10, and then again adding 5 is 15. That is not possible. So the only combination from the previous allowed elements is 3, 2, which is 6 plus 4, 10. And that is possible at this place. So that is 70. So I can write 70 over here. Okay, so before that, I'm just going to repeat the previous value. So 40 and 40, same. I'm going to write 40 over here. And then again, this is interesting. Look at this box. So 40 and 50, which one is the maximum one? 50 is the maximum one. I'm going to write 50 over here. And again, we just found all of these through the formula. And conceptually, this is how they are going to go. Okay, let's solve this last value, 3, 10, using the formula. Let's see if it comes 70 or not. It should come 70. Okay. 3, 10. Okay. So for 3, 10, I minus 1 is 2 and j is 10. So 2, 10 and 30 is the cost. And then again 10 and v3 is 6. So 10 minus 6, 4. V of 2, 4. So if you look in the table, V of 2, 10 is 50, 30 is the cost of the item number 3, and V of 2, 4 is 40. So 40 plus 30 is 70. Obviously, the maximum or the greater one is 70. So we will be choosing this 70 over here. We'll write that. And obviously, we are choosing something from the right side, so keep should be 1. Okay, now let's move on to the fourth column. Okay, I will also change the color of my pointer so that it is more easily understandable. Which color should I choose? I haven't used red on this slide, so let's keep red. Okay, so here, sorry, let's go back here. Oh, I have used red over here. Let me choose some other color. Yellow, no. Okay, well, how about purple? All right, so when I'm allowed to choose item number 4 or any of the previous items and the capacity is 1, what is the weight of item number 4? First of all, the weight is 3. That means this item can come in the bag at this place, right? So I can write 50 over here because that is the cost of this item. This is 50. Please excuse my 5. So yeah, 50 will come over here. 50 is the cost of this 4th item. Okay, how about I choose both of these? So 4 plus 3, 4th item and 3rd item. So that will be 6. 6 plus 3, 3 plus 6, that is 9. Yeah, I can keep 9. So 9 will only come here. This is the allowed capacity, 9. So the total cost will be 50 plus 30 is 80. 9 can come over here. How about I choose 4 plus 2, 4th item and 2nd item. So 4th item is 3, 2nd item is 4. 4 plus 3 is 7. I can do that. 4 plus 7 is less than 10. So, and the value will be 50 plus 40, 90. Very nice. So 90. And 4 plus 3 is 7. So 7, it will come over here. Right, over here. And the cost is 90. Okay. Then, how about 4 plus 1? So 4th item and the 1st item, that is 5 plus 3. 8. I can pick them up as well. So 5 plus 3 is 8 and 50 plus 10. 4th item and the 1st item. 50 plus 10 is 60. So at the place of 8, this place, what will be the cost? 5 plus 3, I'm picking up 1st and 4th item. 5 plus 3, 8. At this place, the cost is 10 plus 5, 50, 60. Should I write 60 over here? You know, the previous value is 90, the next value is 40. No, this is not a good option. So when we are writing values over here, we look at the previous value as well. You just got 90 over here. It is not right to write, not good to write 60 over here. It is less than 90. So no, I will not be choosing that. I will write 90. And is there any other combination? Can I pick up all of these? No, that exceeds the total capacity. Can I pick up 4 plus 3 plus 2? So 3 plus 6, 9 plus 4. No, I cannot pick up that. Can I pick up 3 plus 4 plus 5? I cannot do that. So these are the only allowed combinations that are that do not exceed the total capacity. Okay, now if you look at it, this is 0. Let's fill the remaining values. And 50, and then what will I write over here? 50 and 40. Which one of these is maximum? Obviously 50. I'm gonna write 50 over here, and then again 50 and 40. So I'm gonna write 50 over here, then 50 and 40 again, 50 over here, then 90, 90. Okay, so let's revisit or look at this one again. 90 and 50, and I have written 80 over here. Do you think this is right? No. So I will update it. It should write 90 over here. By the way, when we are doing it through the formula, there is no need to update because formula is doing it one by one in sequence. So we won't have found something ahead of time, and we won't be needing to update it. Okay, where is the eraser? I'm gonna remove this one, and we will write the updated value, which is 90 over here. And similarly 90 and 70, 90 is greater, so we are going to write 90. Okay, let's find this whole row with the formula. Okay, so these are the base cases. They are 0. I have explained them before. Okay, and then 4 comma 3. So putting the values Okay, I'm not going to explain all of this again. You have understood it, I hope, quite well through the previous values and examples. So the answer becomes this 0 and 50. So we will be choosing obviously 50 and keep will be 1. And then when we are putting it 4 comma 4, again this is our choice 40 and 50, and we will be choosing 50 and keep will be 1. Moving on, again keep will be 1 and 50 will be chosen, and then again here 50 and keep will be 1. Similarly, we will choose the right one with the contribution of I, and the value will be 90 and keep will be 1 for both of these cases. Similarly, it will be 90 over here as well as over here, and keep will be 1. So for all of this row, keep is 1 except the first few values. Let's update the keep table as well. We have updated this table. Let's update the keep table as well. So 0 0 0 1 1 this was also 1, I think. Okay, so that's it. Our final answer is here, and we will select by looking we can see that this 90 has come through the contribution of item number 2nd and item number 4th, right? Item number 2 and item number 4. So that's how 50 has come. But how should we do that properly? Through a formula or through a pseudocode or an algorithm? How to do that? What's the logic behind? So for that, what we will do is, this is our logic. We have the keep table. We will check if the value in keep table is 1, that means we have kept that item. If the value is 0, we have not kept that item, right? So basically this is a pseudocode. We will start it from I, and we will run it in the reverse way down to 1. That is, if there are 4 items, I will be 4, and then we will keep decrementing it towards 1. And at each point we will check the value of a keep table, right? So if the value of keep table is 1 at that particular index, then we will consider it and we will subtract the weight. So let's do that. Let's do it with an example. It's okay if you not understood it through the code. Let's do the example. Okay, this is the pseudocode, and this is the example. So for the same example where we have just solved it, n is the number of items, so n is 4, so I equals to 4, and w is the total capacity of the knapsack. So in our case this was 10, right? So w is 10. So this is what I have to see. Keep I comma k. I is 4 and k is 10. 4 comma 10. So what is the value of 4 comma 10? Let me check. In the keep table, this is my keep table. 4 comma 10. Obviously it is 1, right? So that means we will be keeping this item. It is something that is ensuring a good profit. It is one of the combination. It is among that combination which is ensuring the maximum profit. So yes, we will keep it. It is 1. And once we have kept it, you can save it somewhere and then decrement I. And again, to decrement the other index, the column value, you can say other value, this value, what we have to do is we have to subtract from this k the weight of item number 4. So the weight of item number 4 is 3. You can cross check if you don't remember it. The weight of item number 4 is 3, right? So total capacity is 10, which is basically k. So 10 minus 3 is the next value. So we will look at v3 comma 7, and the keep value of v3 comma 7 is 0. You can cross check that as well. So that means we will not be keeping this item, and then decrement I again, and that is 2 comma 7. So at 2 comma 7 the value of keep is 1. Let's check it. At 2 comma 7, to second row, 7th column, the value of keep table is 1. So we will keep this item, right? So we will be keeping this item. And then since we are keeping it, I'm going to subtract the weight of second item from this 7. The weight of second item is 4, right? So it is 4. So 7 minus 4 is 3. So next I'm going to look at 1 comma 3. The value of keep at 1 comma 3 is 0. That means I will not be keeping this item, and that's it. Again, decrement I, and the loop is over, right? So because the loop was only allowed to run till 1. So that means we are keeping the fourth item and the second item. That's how you do it. I hope you have understood it. If you have any questions, please let me know.